So in this video, we're going to do our first example doing regression for a problem. So let's first just read through the problem and see why we're inside this module. Suppose we want to predict number of points scored in a football game based upon the team's total yardage. So if I look at my two variables, we have number of points, which is quantitative, and their total yardage in the game, which is also quantitative. And so I want to see how one is affecting the other. Now, as we mentioned before, one of the first things I have to figure out once I have these two variables is which one is the response variable. Which one is really the outcome of interest? Well, what I really want to know is how many points scored, right? That is what I want to predict. That's what I want to know. Now let's go ahead and look at the scatter plot we created here. So yards is our x variable, points was our y variable, and we're going to interpret this in the context of the problem. Right, so the relationship between total yards and points scored so does it seem straight enough? Seems pretty straight or linear to me. I don't really see a curved pattern. And it seems to have a positive slope. More yards tend to lead to more points. So we have that first question answered. All right, how strong would you say this relationship is just from looking at the plot? Somewhat, maybe it's not real strong. So I will just say that it is somewhat strong. And then do you see anything unusual in the plot? Nothing really seems to stand out to me. All right, so now really getting into the regression side. So first I'm actually going to do is show you how I got the StatCrunch plot as well as this output that you see, and this is abbreviated compared to what we're going to see in StatCrunch. So let's talk about how I got this first. So first I have my data set here. I've loaded into StatCrunch. Again, to get that scatter plot, we just go to Graph and Scatter Plot. My x was my yards and my y was my points to get my scatter plot. Then to get this output, my goal here is to get the slope and the intercept that we talked about in the previous video. I'm just going to go to Stat, Regression, and we will only be choosing the simple linear option. And then here I'm just putting in again my x and my y. At this point, we're not even going to worry about any of the other options. We'll talk through those later that we will need. And you get all of this output where I've rounded some of the numbers and sort of deleted some of the output right now. So looking at our output here, the main place we're going to focus right now is down here in this parameter estimates. So there's an intercept of negative 9.81 and our slope of 0.0969. So that's going to help us write out our equation. So our y hat then is, our slope is 0.0969 times our x, and then our intercept is negative 9.81. So that's putting it in this form that we talked about in that previous video. Just because remember, this is our B1, X, and B0. Alright, now let's worry about the interpreting part. So let's interpret slope first. I'm starting with slope because we will always interpret our slope. So it's a pretty small number, it's 0.0969. It's positive, like I expected to see here, that positive slope. So what this means, so if x increases by 1, I expect y to then go up 0.0969. All right, let's put that into context to see if this makes sense. So if I have an additional gain of 1 yard, right? X is increasing by 1. We expect points scored to increase by 0.0969 points. And so even though it's small, it sort of makes sense here because every time I gain a yard, we're not scoring a touchdown or something. Right? It takes a lot of yards before we really do score. So a gain of 1 yard, each time we do it, is expected to increase by 0.0969 points. Now let's talk about this intercept. Now I mentioned when we first talked about intercept, sometimes it's going to make sense to interpret, sometimes it's not. So how do I decide? There are going to be 3 questions we're going to ask. We're going to ask if x can equal 0. So what is x in our case? So x is yards. So is it possible in a football game to have 0 yards? Pretty boring game, but it is possible. My second question is, can y be close to the value of b0? So y is our points, and our b0 is negative 9.81. So is it possible to score a negative 9 to 10 points in a football game? That is not possible. Telling me I'm going to not interpret my intercept. If we would have got to the third question, so I'm going to go ahead and list them all here, is to see if we have any data near x equals 0. So I would compare the plot. Well, where is 0 along my axis? Well, somewhere over here. Like, right, so I don't have any data there as well. But as soon as I hit 1, where my answer is no, there's no need for me to interpret my intercept. All right, doing a couple more questions attached to it. So suppose that we would like to find out how many points we would expect the team to score in a game if they had 400 total yards. How could I do this? Well, this 400 total yards, that's a value for x. And I already have this equation that we wrote down on the previous page. Right, so if I just substitute an x of 400 in here, that will get me my predicted number of points scored. So we're going to predict roughly about 29 points for the team to score in that game. As a follow-up, does that mean that they will score this many points if they have that many yards. It's not a guarantee, right? It's just a prediction. They could score that many, but again, it's just a prediction. That's why it's a y hat value, is it's a prediction. All right, so there's an intro example to understand slope and intercept. In the next video, we're going to start talking about the hypothesis testing for our relationship between two quantitative variables.